We're ready for our next learning objective, and as it says here on the screen, we are going to be talking about buffering capacity and how to prepare a buffer of a specific pH. Well, to do this, you first have got to choose the right substances to be a part of that buffer. And you want to choose an acid whose pKa value is close to the desired pH you're looking for. Now, why would that be? If we think of the Henderson-Hasselbalch equation, which applies to buffers, the pKa value of the acid in that buffer is going to be your starting point. This term, how much base and how much acid you put in there, that ratio of base to acid will tweak it up or down depending upon whether you need a little bit higher than that pKa value or a pH a little bit lower than that pKa value. But you want to start with an acid whose pKa value is close to the desired pH. If you're looking for a buffer that's in the acid range, meaning less than 7, okay, you're going to be going to tables of acids, you're going to be looking at those acids and finding one whose pKa value is close to where you want. But if you wanted to make a buffer that has a higher pH, let's say greater than 7 in the base range, then you want to be choosing a starting material which is a base, so that you've got a basic buffer. But again, you're going to be looking at the Ka value of its conjugate acid. Okay? So if you were looking at a base like ammonia, you need to consider the acid ammonium and say what's the Ka value of ammonium and get its pKa value. So you're looking for something that's in that range. Once you've decided the substances that will make up your buffer, then you're going to take that Henderson-Hasselbalch equation and you're going to solve for the ratio of the base over the acid. And that way you'll know how much, what concentration of those two items you're going to need in order to make that pH. You might also consider it in terms of moles of base over moles of acid instead of concentrations. And then once you know how many moles of each you're going to need, or the ratio of moles that you're going to need, then you can say, well, how many grams would I need to weigh out to get that many moles? Or I'm going to do a dilution and I'm going to figure out the molarity and the volume I need to get that number of moles. Now in this problem, I've already told you what the substances are that are going to be making that buffer. And I'm just going to show you the idea of solving for the ratio. If we consider the Henderson-Hasselbalch equation, pH equals pKa plus the log, and I'm going to do it in terms of moles, number of moles of base over number of moles of acid. I'll plug in that I'm trying to obtain a 4.80 pH, and I'm going to use the negative log of the acid, which is 2.0, times 10 to the minus 4. My goal will be to solve for the log of, the number of moles of base over the number of moles of acid. The negative log of 2.0 times 10 to the minus 4 is 3.70. So I will subtract 3.70 from both sides and have 1.10. And now we've got to get rid of the log. Log function, inverse log is 10 to that value. So those will cancel, and we will be left with 12.6 equals the number of moles of base over the number of moles of acid. Another way to write that would be 12.6 times the number of moles of acid would give you the number of moles of base. So at this point, you have all sorts of values that would work and give you a pH of that amount. Let's say we'll choose a 0.10 moles of the acid. If we choose that amount, then we will know that if we multiply that by 12.6, that would give me the number of moles of base I would need. In other words, I need 1.26 moles of base. So if I made a solution that had those two amounts, 0.1 mole of acid, 1.26 moles of base, then I know I will have created a buffer with a pH of 4.80, which is what I was trying to achieve. It doesn't have to be 0.1 moles. I could choose any amount here. Let's say I want to have more acid, more base. Maybe I want to have whoops, I'm still using my eraser. I want 1.0 moles of acid. Well, that would tell me that I would need to have a solution with 12.6 moles of base in it. But whatever, that ratio has got to be 12.6 to 1. Now, buffers will quit working after a while. You add an acid, it'll drop the base portion of that buffer down. You keep on adding acid, you'll keep dropping it down. Buffering capacity is the amount of acid or base that you can add to that buffer without causing a large change in pH. Eventually, you wipe out the buffering capacity. You have used up these substances, and you no longer have a good ratio of conjugate acid and conjugate base pairs in there in your buffer. If you look at this diagram down here in the bottom right, we see that they both have the same ratio of base to acid. So the number of moles, if we let each one of those figures represent a mole, the number of moles of base, the number of moles of acid is 4 to 4 or 1. Over here, the number of moles of base to the number of moles of acid is 2 to 2. It would have the same pH, and it would have, but one has a better buffering capacity than the other. So anytime you increase the concentration of the acid or the base in your buffer, then you increase the capacity. So let's erase what I've got on here so it doesn't mess up what's popping up next. We've got a dilute buffer, we have a concentrated buffer, and certainly the concentrated buffer has a better buffering capacity. You could also do a ratio of acid to base, and I will maybe draw it in like this. Let's say I've got 4 of the acid and I only have 2 of its conjugate base. If I have a buffer like this, it has a good buffering capacity to neutralize an added base, because there is quite a bit of acid in that buffer. But it wouldn't have as good a buffering capacity against added acid, because the added acid would be neutralized by the base form of that buffer. So you could have a buffer in this case, because you needed a certain pH range, that would be more effective against the addition of an acid versus addition of the base, and vice versa. This is just a diagram that we've seen earlier, and we can imagine in this one if we had less acid to start with than we had base. And so we're starting off with this down here and not all of this up there. We just have a less amount of the acid. That this buffer would be a good buffer against added acid, because there was quite a bit of the conjugate base in there. But it wouldn't be as effective against added base because I'm starting with a lesser amount. So that's the end of our learning objective for 4. You know what buffering capacity is, and you know how to create a buffer that has a specific pH range.